So Jerry, I appreciate that and your work on that topic. Okay, so next question here. Here's another one I've seen recently. We host a lot of debates here on the channel as well. And it's kind of, it's an aspect in a way of the vestigial organ argument. And it has to do with so-called bad design. So proponents of common descent or the theory of evolution look to the recurrent laryngeal nerve as evidence for bad, is that in the giraffe, I think, perhaps? For bad design and therefore no design. And I know you've written an article on this, if I'm not mistaken, in at ICR. And so what's a good response to that?
I've written several articles. I have a chapter on that in my book. Basically, the design of the recurrent lingual nerve exists for at least 4 different reasons. And so it's not poor design. What the concern is that instead of going directly to its goal, it goes around and turnabout. It's like, I'm going to your house, and therefore I go to Toronto first, and then I walk back to your house in where your city. And so that's not a very wise route to take, because I'm spending a lot of time going somewhere else. I'm backtracking to get to your house. But the recurrent lingual nerve, they claim, does that same thing. But the fact is, there are good reasons for at least 6 I mentioned for the recurrent lingual nerve to be designed the way it is. Number one, it works pretty well. And so it works very well. And so I haven't, in the medical field, haven't heard any concerns about this so-called poor design causing problems. And so it does work pretty well. And there's a drawing which I use in my book, which I can use to show that better, but you probably don't have a copy here. But next time maybe I do a show, we can point out that specifically. But one point I point out is the timing. And when signals are sent, it takes so long to get to where they're going. And if signals get there too early or too late is a problem. And so the recurrent lingual nerve, among other functions, it causes the signal to get there at the right time, not too early or not too late. And I'm not sure that's talked about much in the medical books, but that's one issue that came up, which I thought was a good argument, that there are good reasons time-wise. And that's true with all nerves, of course. It has to have a journey, and that journey has to arrive at the location in a specific time. And too early, too late, it's a problem. It causes uncoordination if it's too early or too late. So coordination is critical, and that means the signal has to get there when it needs to be there to coordinate the host system of talking.
Very good, Jerry. So in other words, it's not an example of bad or poor design as the evolutionary community purports?
Not at all. It's an example of not good, but ingenious design the way it's designed.
That's awesome. How does, I kind of find the argument from bad design to be humorous. We understand there is no bad design, but let's just entertain the idea, bad design. Does that equate no design or no designer? I mean, especially in the human design world, there's many of bad designs we could point to, but it doesn't mean that those things weren't designed.
Right. They try to show it's bad design and therefore it's no design. And of course, that argument is fallacious. It may be even true. It may be a bad design, but that doesn't mean it's not designed. And again, what I'm looking at is what appears to be bad design. When we look further into it, turns out to be very good design. I mean, you can say that, well, humans can only do 1 or 2 things at a time. Wouldn't it be nice if humans had the abilities that some animals do, and we can do 2 or 3 things? We can have smell like a dog. We can have vision like a eagle. We can have brain response like, I don't know, a computer. So why can't we have all of these things? Well, there's a good reason why we can't have all of these things, and that would be information overload. And that is a problem with, well, every mother with screaming kids and a husband he's trying to take care of and so on. Well, we all recognize over-design, overstimulation. Autistic persons, for example, are easily overstimulated by things to us that don't bother us. The furnace goes on, the refrigerator goes on. That is stimulus that bothers them because they are overstimulated. We can deal with that. But autism is a neurological disorder where this coordination is not as it should be. And so to have more sensitive smell or more sensitive eyes that can see better could be a problem because not only of over-design, but also because it may interfere with effective picking up information. we tend to hear in frequencies that people talk in. And so the frequencies from 20 to 100,000 hertz. So there's a huge range there. And our ears are designed to hear primarily the range that people talk in. And so we pick up voices of people very effectively, and we don't pick up other noises which are there. I learned this, by the way, by tape recording when I went to medical school. I had a tape record all my lectures, and I played them in the car on the way home because I had an hour drive, and I thought that's a good review. And when I played them in the car, I could not follow them very well because all the noises, the other noises, that when the heating, the cooling went on, you could hear that and overpowered or at least interfered with the person speaking. And so then I realized what was happening was my hearing system is designed to pick up effectively voices and filter out the flow of air caused by the air conditioning system. But the tape recorder I had wasn't designed to do that. And therefore it picked up all those noises. And therefore when I played the tapes in my car, it was much harder than it should be to listen to my professor.
Very good, Jerry. I think there's another clip-worthy moment on that topic of bad design. Here's a question that comes in, and it is from Andrew Cumming here. And so the question is, what's the purpose of some animals growing certain organs early on in embryonic development? Might be good, Andrew, if you wanted to provide us a specific example, only to lose them later on as infants. Jerry, do you have any thoughts on that?
Yeah, and the embryo, you realize, has to develop the organs necessary to survive at that stage of development.
Right.
And therefore, the nervous system matures first, because the nervous system has to be able to coordinate the body system, and therefore it matures first, and therefore human tails are very prominent. Of course, it's not a tail, it's the nervous system. The spinal cord develops first because that coordination must take place early in the life of the infant. Later on, its other organs take over, and the nervous system, of course, doesn't, in this case, degenerate, but it develops a certain point much earlier than it would seem to need to. And then later on, of course, it does, other organ systems catch up. But another example, I think, is blood. Blood is not produced in the infant until late. And that's because the infant's primary supply of nutrients and oxygen and elimination of waste comes through the placenta. And so the organism has a system of producing the needs, the oxygen and needs, as well as elimination of the waste needs. And therefore it has that because of the placenta. And therefore the system that produces blood cells does not develop until much later because it's not needed until much later. The same thing with the lungs, of course. The baby doesn't use its lungs when it's in the infant, when it's in the embryo. And therefore, when it is born, the lungs have for the first time to be used, but they have to develop only necessary to work when the baby is born. And so therefore, the development lags in the development of the lungs when the baby is developing.
Well, that's an excellent response, and I had not thought of some of those points, Jerry. That's really good. I think that's why these discussions are important, especially addressing some of the critics here. And so these structures that, because I know there's many examples of structures or organs being present in embryonic development, and then over time they get reabsorbed. So during those times that they're present, they're essential. They're critical for those stages of development. And then once they're no longer needed or useful, then they're either reabsorbed or repurposed into a different structure. So I'm wondering, because I've seen evolutionists, Jerry, point to, I think it's dolphins, and they'll say, oh, dolphins, they, in early stages of development, they have these limb buds, arm and leg limb buds, and then eventually those are reabsorbed. And so they extrapolate that to mean, well, that must mean that dolphins are descendants of walking mammals, as you know, with whale evolution. So I guess my question would be, why do you think those limb buds, if that really is the case, this is their assertion, in dolphin embryos, how come those limb buds are present for a time and then they're reabsorbed?
I understand those limb buds are developed to coordinate the rest of the system in order for it to develop. It's kind of like a scaffolding, which is placed in the building to put the bricks up. But once the bricks are up, you don't need it, and therefore you can take the scaffolding down. So the limb buds, and there are other structures as well, which are necessary as part of the construction, but not necessary once the construction is finished. And so limb buds would be a attachment point to allow other systems to develop until, of course, they're developed, and then they're no longer needed. So then, therefore, they're reabsorbed. But there are actually quite a few structures that are temporary that are developed in animals. But the problem I see is people look at these and they make extrapolations or interpretations based on evolution. And they often turn out to be wrong because we realize now there are reasons for this development and it has nothing to do with evolution. So when we see what appears to be a organ that develops and then dissipates later on, well, that's because of evolution. And that kind of answers it, but it doesn't. What we should say is, well, it could be because of evolution, but may not be. So let's do more research and find out what these limb buds are for. Then, as we do research, we may find out that they're for a very specific reason during the development of the organism. And therefore, we can avoid these wrong roads that saying, well, it's because of evolution. In many ways, evolution is a knowledge stopper. Well, why is this the way it is? Well, it's because of evolution. End of story. And we ought to say, why is it the way it is? Well, I don't know. Let's try to find out. So we close doors, I think, with the evolution explanation.
Yes, we close doors. Yes, I think that restricts scientific advancement, and that would be the mature and responsible approach and thing to do. And so I like the way you put it there. I think that's great. I think this is an excellent response that people need to consider as they are confronted with these evolutionary arguments, whether it's online or in person, that these structures like the limb buds, they're a necessary part of the construction during the process, but not necessarily, but not required for the final product. And so that's why they can be reabsorbed. What about for the animal in embryonic development to move around and shift? Maybe those so-called limb buds could be used for those stages for a purpose like that, just to move around and shift, and then eventually they're repurposed until more structures come about. I think the main point, and correct me if I'm wrong, Jerry, is what we observe here does not necessitate evolution. These evolutionary extrapolations are not necessary. They can have other reasons or purposes.